Hello friends, in this video we will be starting with static and dynamic system. Let us begin. Definition of static system says all memoryless systems are static system, and if systems are equipped with memory then it is a dynamic system. Now for example, to give you some real time examples, let's say we are talking about some digital circuits. You know that digital circuits are classified into two categories, that is a combinational logic circuit and a sequential logic circuit. Is that right? In fact, sequential logic circuit is combinational logic circuits along with memory. So we know that there is no memory inside combinational logic circuits. So all combinational logic circuits are categorized as static systems because those are memoryless systems. But a combinational logic circuits along with the memory, which forms a circuit called as a sequential logic circuit, is called as a dynamic system. Right? Now let's say we are talking about some electrical circuits. In electrical circuits, we have three important elements, that is resistors, inductors and capacitor. By property, resistor is a non-storage element. Okay, non-storage element means it is not going to store any energy, whereas when we talk about inductor and capacitor, they are energy storage elements. Like inductor stores the energy in the form of magnetic field, and capacitor stores the energy in the form of electrical charges. So something that stores is what we call as a memory. Is that right? So any electrical circuit which will have inductors and capacitor inside it will be called as dynamic circuits, or according to the system point of view we can say those are dynamic systems. And let's say if a particular circuit having only resistor network inside it, then that is a memoryless system because it cannot store any energy. Is that right? And therefore those circuits would be called as a static circuits, and from system point of view I can say that it is a static system. So I'm sure now you got enough idea what is exactly meant by static system and dynamic system from real time system point of view, right? So let us understand in signals and system subject what is exactly meant by a static system and dynamic system. So if present output is a function of present input, so now it is very simple. See, suppose you applied some input and it gets reflected into output, right? Second time if you apply some input, then you will get a new output. This new output will not be a function of what previous input you applied. Is that right? Because there is no memory to store, right? Since those are memoryless systems, present output will be purely function of what you have applied currently, or that is called as a present input. So if present output is only function of present input, then it is called as a memoryless system, or it is called as a static system. For example, your present output is function of present input and or past input. So as you can see that a present output is not only function of present input, it may be function of only past input, or along with past input some present input also, and or future input. In that case we say that there is a presence of memory and the respective system is called as a dynamic system, right? So I'm sure now what you are wondering for, it is quite convincing to you that present output depends on present input or at the most past input. But how come we can have a system where present output depends on a future input? Because logically future input would be applied in future. Is that right? So how come present output it gets reflected what you will be applying in future? How system will come to know that in future what type of input you are going to apply? So of course practically it is not possible to construct a particular system where present output would be a function of future input. But then hypothetically it is possible, or virtually it is possible. For example, now I'm recording this lecture right now, but when it will come as a product in front of you, it would be a recorded lecture. Is that right? So when it is a recorded lecture, and let's say you're watching a particular content right now, so this is a current time you're watching something, right? But you can just fast forward it and you can go to future, okay, and At current time only you will come to know what I'm telling you in future. So it is something from the recorded lecture you are able to see the future inputs also. Is that right? So virtually speaking, yes, it is possible to construct a system which are dynamic system. Is that right? So whether it is past input or in case of future input, that is in terms of recorded lecture I'm talking about, it is possible only when there is a memory inside your computer. Is that right? Or if there is a memory on the server, if you are watching this online. Without memory, it is not possible to have a system where present output would be function of past input or future input. And therefore, we say that a system which is equipped with memory is called as a dynamic system, and a system which is completely memoryless is called as a static system. As we discussed for digital circuits, we can say that multiplexers, demultiplexers, or let's say encoders, decoders, all of them are combinational logic circuits, and all of them are called as a static system. Whereas when we talk about latch or flip flop or counters, all of them are example of what? Sequential logic circuits. And we know that sequential logic circuits is basically combinational logic circuits along with memory. Since it is a presence of memory, then they are called as a dynamic systems. So now you got enough idea what is exactly meant by static system, what is meant by a dynamic system. But now let us think about from gate point of view. In gate point of view questions, what will happen? That they will give you a equation where output of system will be expressed in terms of its input. That is, let's say y of t is expressed in terms of x of t in some mathematical form. And looking at those mathematical form, you have to guess whether it is a static system or dynamic system. Let us start with some examples. So look at question number 1. In this, we have to identify which systems are static or which systems are dynamic here. What you need to do, read the equation. It says y of t equal to x of t minus twice of x of t whole square, right? So what I can do, at let's say t equal to 0. At t equal to 0, I will say it is y of 0. Remember, now whatever time instant you are writing over here becomes a present state, or it becomes a present output now. So y of 0 is called as a present output because that is the time instant you are now looking for. Is equal to what? X of 0 minus twice of x of 0 square. So I can write x square of 0 also. Is that right? So now look at this. This y of 0 is called as a present output. Why it is called as present output? Because y of t is called as output, x of t is called as input. If y of t is called as output, and if I assume that at t equal to 0 instant is considered as a present state time or present time, then it is y of t at t equal to 0 would be considered as present output. Whereas x of 0, now x of t stands for input, then x of 0 is called as x of t at t equal to 0. So I can declare that this is a present input. Is that right? Whereas x square of 0 means it is x square of t at t equal to 0. So this is also a present input only. Is that right? So in this example, what you see, your present output depends on present input only. But you don't have to come to the conclusion until and unless you take some example also. Let us go for one more instant. Let's say at t equal to minus 1. So now t equal to minus 1 becomes a current state. So let's say when I say y of minus 1, it means it is y of t at t equal to minus 1, or it is considered as present output will be function of x of minus 1. So what is meant by x of minus 1? X of minus 1 means it is x of t at t equal to minus 1, or we can say it is a present input minus twice of x of minus 1 square. Is that right? Now what is x square of minus 1? X square of t at t equal to minus 1. So this is also a present input. Am I right? So whatever t instants you try over here, for all those examples, you will see that present output always depends on present input only, and therefore we can declare that the first question belongs to static system. So this is a static system, right? Let us start with second example now. Second equation says y of t equal to x of t minus 1. So always assume that x of t is input and y of t is output. So at, let's say, t equal to 0, I can say that y of 0 is equal to x of minus 1. Am I right? Now what is meant by y of 0? See, y of 0 means y of t at t equal to 0. So whatever instant that you have written here, okay, always becomes a present state or present time. So I can say that this is a present output. And x of minus 1 means what? X of minus 1 means it is x of t at t equal to minus 1. Is that right? So if you see on a time scale, let's say this is 0, this is 1, this is 2. I mean, these are positive time scales. This is t equal to minus 1, t equal to minus 2, and so on. Is that right? So the instant that you are talking about is t equal to 0. So t equal to 0 becomes a present time. So this is a present time. Okay, this is the time that you are looking for. Now, whatever time instants present over here, that is after present time, refers to future time. Is that right? So whatever instances which are present this side, that is left side of the present time, are called as past time. Is that right? So for example, if you have something as x of 0, then it is called as a present input. If we have some x of t which refers to future values like x of 1, x of 2, and so on, then those are called as future inputs. And whatever x functions which are lying over here are called as past inputs. Am I right? Therefore, x of minus 1, okay, x of minus 1 is present here, and t equal to 0 is present here. So when I say y of 0 means this is called as a present output. So this is the time instant we are looking for, but then it is a function of a previous input or a past input. So I can say that since output is function of past input or present output is a function of past input, therefore I can say that this system is a system equipped with a memory, and therefore it is a dynamic system. All right? So this system is a dynamic system. Let us see more examples. So now you have y of t equal to x of t plus 1. So again you can start with at t equal to 0. So at t equal to 0 becomes a present state or present time. So what is meant by y of 0? Wherever there is t, you just go on replacing t equal to 0. So y of 0 equal to x of 1. So when I say t equal to 0 is a present time, then this is called as a present output. Is that right? You know that x is input or output? Of course it is input. Now you have to only decide whether it is a present input, past input, or future input. If you say t equal to 0 is a present time, then of course t equal to 1 would be coming after t equal to 0. Therefore it is called as a future input. As you can see, a present output is a function of future input. You know that strictly it should be quite clear that present output should depend on present input only, then and then only it is called as a static system. Otherwise it is a dynamic system. Therefore this is a dynamic system. You can just take one more example here. Let's say at t equal to minus 1, then it becomes y of minus 1, which is equal to x of minus 1 plus 1. Okay, or I can say y of minus 1 is equal to x of 0. So what is meant by y of minus 1? Y of minus 1 means y of t at t equal to minus 1. And of course, when I'm talking about t equal to minus 1 here, it means this is a present time. So this is called as present output. Then x of 0 is of course something which is going to come in future. Therefore, this is called as a future input. So as you can see, every time present output depends on future input. Okay. So present output, when it depends on either future input or past input or both, okay, then it is called as a dynamic system. So we have one more example now. Y of t is equal to x of 2t. Let's say at t equal to 0. Then y of 0 is equal to what? X of 0. So here we can say that present output depends on present input. So don't come to the conclusion right away. Just take few more time instants and then only write the final conclusion. Let's say at t equal to 1, y of 1 will be equal to x of. So now look at this. When I say y of 1, okay, since I'm talking about at t equal to 1, then it becomes a present time. So at that time, output status is called as a present output. So of course, x of 2 is called as future input. So here, present output depends on future input. I'll take one more example. That is one more time instant. Let's say at t equal to half, then it becomes y of half. Okay, t equal to half means 0.5. So y of 0.5, that is y of t at t equal to 0.5, or y of t at t equal to half, which is x of 1. Is that right? So now if you see on a time scale, this half and this is 1. Is that right? So this is when I say present. So t equal to 1 becomes future. So again, present output depends on future input. So every time you see present output, in first example we saw that it depends on present input, so we think it is a static system. But then in these two examples, it depends on future input also, therefore it is dynamic system also. In such cases, what needs to be done? So now I'll make it quite clear. First of all, let me declare this is a dynamic system. This is 100% dynamic system now. So sometimes it happens that few examples shows that it is a static system and few examples shows that it is a dynamic system. In that case, how to choose whether it is static system or dynamic system? So now let me make it very clear. For example, let's say there are 100 cases. There are 100 cases which says that it is a static system, but only one case says that it is a dynamic system. Then you have to go for dynamic system, because even if one case is present which belongs to dynamic system, it means it is definitely having some memory element inside it, and it is 100% dynamic system in that case. So maybe there are 1,000 cases which shows it is a static system, but even if one case is present which says it is a dynamic system, then it is 100% a dynamic system only. It is not a static system. So note this point, it is very important. It happens with students that they just try this example and then they see that the present output depends on present input, and they come to the conclusion that this is a static system, and everything goes wrong, right? So try with different time instants and try to identify whether it is a static system or dynamic system. Identifying static or dynamic is very easy, right? Thank you.